Here's some early work that I did. This is the 2002 work. I still owe my dad for the actual start money to get it published. Sure like to pay him back someday. Uh, anyway, I've proven this creation epoch. Hello, this is Todd Gooch, author of the Gravitational Unit Theory, Unified Field Theory. Pretty much theory of everything. Total mass of the universe was next contained within increasing volumes of a permeable spherical geometry known as the Big Bang. Uh, this is when the first law of physical geometry that we're dealing with today comes into effect. I've never found an exception to this statement that the universe is composed of permeable spherical gravitational units, G units, uh, with spin and have a diameter on the order of a Planck length and a mass on the order of a Planck mass. I go on to say that the strong force, the gravitational force, and electromagnetic weak force are consequences of the universe being architected from gravitational units. uh, that was good for about the first 8 years of my research. I went on to use that to do many things, including standardizing the square root of 2 to a meter, which I calculated all the way down to the Planck length, and negated our current meter as valid as a unit length. Uh, this statement took me 8 years. I was on the brink of quitting the theory um, around the year 2000, and I was thinking to myself, well, if I don't have a breakthrough of some sort, I'm just simply going to have to give up. But what I came up with was that a permeable spherical geometry could be could be used to describe the universe. And what had happened was that I stagnated down at the Planck length, and I really could not figure out how to uh, journey all the way up to the size of the atoms. But when you use this statement that the same geometry that's occurring down there could be used to describe uh, larger particles, then you can start to do the work on the atoms. Um, then go on to propose the actual theory and start to define the gravitational unit. That a G unit is defined as a spherical Planck mass with a diameter of a Planck length whose nature is to be semi to fully permeable to other G units and to spin. I go on to say that the G unit has mass, volume, and spin, and talk a little bit about its relationship to the Planck time. Uh, this is very important in 6. Two units are defined to be adjacent if they share a common volume. Um, and R is defined as the distance between the centers of two adjacent G units, an interval of 0 to 2R, inclusive on one side. Um, R can be used to describe a variable unit length and to calculate the new meter such that there's a whole number ratio uh, that works for the square root of 2 for that meter at the Planck length. Um, and that's calculated in the current version of the book, Gravitational Unit Theory, Unified Field Theory. I get down here to force is defined as the mass of gravitational units moving at an acceleration. And at the end of these review videos, I'm going to actually calculate sample problems for all of the four forces using a single equation. And I encourage everybody to tune in for that. I'm going to stop this first video here. Thank you much for your time. My name's Todd Gooch, and I'm the author of the Gravitational Unit Theory, Unified Field Theory. Hello, this is Todd Gooch, author of the Gravitational Unit Theory, Unified Field Theory. This is very important to the theory that between G units exists no space that is not occupied by a G unit, a gravitational unit. The reason for this is that the total mass of the universe must remain constant, and that's definitely the only way to do it. If you had holes, rips, and tears, the first law of thermodynamics would be violated, and it pretty much immediately negates the concept of string theory, which relies on these rips and tears in the fabric of space-time. Also, loop theory has the same problem with its theory, and that is that at the basic level, you would have these gaps or holes, which, because of the geometry of the loops, which would have the chainmail geometry of the loops, which would have a gap in between them. Only through the use of the permeable spherical geometry, which I propose, can you solve these particular problems in theory. I go on to talk about that as a result of that, there is no true vacuum, and the vacuum of space that we see. Now, this book was written in 2002, and they certainly weren't saying this back then as much as today, where we're starting to acknowledge that space might actually be made up of something, although it's still something that your physics professors certainly don't like to talk about, because the standard model's in error and its assertion that the vacuum of space is empty. Now, here's something important that comes out of it. Is that an alternate way to view the maximum value for the speed of light, c, is a terminal velocity due to the drag of the fabric of space, such as an object which falls through Earth's atmosphere. And that's the view of the gravitational unit theory of the constant nature of light, is that it is a terminal velocity due to the drag of the fabric of space-time itself. And that's why you cannot exceed its limits. The theory continues to go on and not violate the first law of thermodynamics, or but at the same time, it talks about the notion of zero in the universe. This is more of a physical concept. That there is no area in the universe which does not have mass, is basically what it's saying. So there's no zero mass areas of the universe. Let's see where we go on. And here we move on to a completely different section, but I'm going to continue on. The gravitational units, as a consequence of the permeable spherical geometry, naturally arrange themselves as octahedral polygons, G-octahedral, with a doceptahedral 14-sided configuration. And I use this in the corollary I was talking about earlier, that allows me to use the permeable spherical geometry at a larger level, to go on and talk about, well, actually I didn't need it for this particular work. Trying to focus the camera. This is these were the dimensions for the photons, and then let me go ahead and show you the photons. the actual geometric constructions of them. This early book was very good for that. I did a lot of the artwork in it. Um, Red photon is on bad background paper. Orange photon geometry. Yellow photon geometry. Green photon geometry. This work was done in 1993 originally. Uh, Blue photon. Uh, it was just rescued in 2002. Indigo photon. And then violet photon, which I presented. I presented these to my art class in '93, I believe, as an art project. Um, so gravitational unit theory can be used to draw the photons. Well, this is an octahedral geometry, symmetrical octahedral. These are symmetrical on all three sides. These particular images are cross-sectional views of the photon, but it's very easy to see the three-dimensional symmetry of the uh, if you want to call it a particle. I prefer to call the monochromatic photons more of a wave, and then the white light photons to be more particulate in nature. Um, but, but that's just because what the geometry says to me. Uh, Now, when you make them non-symmetrical, you can draw all of the atoms. Like here's hydrogen, top view. I guarantee it looks exactly like that because I predicted years ago that they would have triangular electron shape, and what we see is that in today's actual photographs, microscopic photographs are coming up with triangles just like I predicted. There's the top view, there's the bottom view. Well, this is something new for hydrogen because this is a bonding site. While the dark triangle is your classical Bohr concept of the electron, this is something that the standard model doesn't acknowledge. And it's the only if you use key and keyhole theory can you actually draw the cycloboranes. And I'm actually the top in my field, presented at the American Chemical Society meeting 2010. I'm the only person in the world that can draw B10H16 successfully without having to use the dotted lines in molecular orbital theory, because I have my own structures in my own copyrighted periodic table 2007. Here's the front view of hydrogen, and then the back view of hydrogen. Uh, Here we go. Helium, same thing as hydrogen. That's important to point out. Except its bottom has the other triangle flattening out the octahedral. Here's the front view of helium, and then the back view of helium. Uh, the inert elements pretty well represent the entire period of whatever you're looking at. Here's lithium, top view. Notice the underlying helium structure that it rests upon, and the dark triangle on top denoting its one bonding electron in this case. Um, this is the bottom view of lithium. This early book was just great with the artwork that I had done. Lithium front view. I would like to remind everybody out there that I'll be doing all four forces, the theory of everything. I'll actually be doing sample problems of gravity, electromagnetism, the weak and the strong force at the end of these videos, these review videos on the theory, just to prove I have the theory of everything. Dr. Hawking, Dr. Keku would like to see it. and their whole group said that they would and were interested in person stepping forward if he could actually do them. Here's beryllium and beryllium front view. And well, since I can actually do them, I'm going to go ahead and do them out here on YouTube and Facebook and Twitter. I hope everybody, helps me out financially. If you would purchase a book, it would help me out. This would definitely give me a little pocket change that I need right now. I get a portion of every sale. It's gravitational unit theory, unified field theory, the theory of everything. I propose a new meter in the book. It does not have all these photos though, and I'm almost having to come out with another book in order to, because I've reached the maximum that I can put in to my current book for everybody. Here's carbon, by the way. Everybody's interested in carbon. Here's the bottom view of carbon. The 3 bonding electrons you can see on the bottom there. You can see the geometry of the helium inside there, which it keys off of geometrically in order to actually draw these pictures. Again, I predicted that the triangles would be there, and anybody that wants to go look on current microscopic pictures of of the atoms, you'll see triangles are what you see on the surface there. I mean, you just can't get around it. The theory's correct. It made the prediction. Prediction came true. Last time anybody did that was Albert Einstein when he said that the light would bend around the sun. So I'm telling everybody, hey, I've got it, and I'm going to actually do it out here and show everybody that I've got it. I'm copywriting it as I go on through these videos, so that when I do put it out there, that I do have my copyright on whatever is copyrightable. You just never know these days. Anyway, we're getting towards fluorine here. Front view, back view, and then we hit neon, and you can see it really does represent the entire period that it's in. There's the front view. Notice how I call it the non-symmetrical gravitational octahedrals. Notice how it's kind of flat. More symmetrical on two sides, but one side's flat. These atoms seem to be heading towards, from non-symmetry, the non-symmetry of flatness of the hydrogen atom up through the ball-like shapes that you start to see as you get up here into the 4th and 5th periods of krypton and xenon, which also key off of and here's krypton. They key off the earlier pictures. Now here I had to do this by hand. It took me weeks in order to actually come up with the correct geometry, but that's it. That's what krypton looks like. It just became far too complex to continue to do with the compass and straight edge. You really had to think it out for some time to get the right image, and that encompasses the geometry of the 6th and 7th periods. I put my name on the 18th element, in 118th element. I call it Guccium. I beat the Russians to it 6 months ahead of time to the electronic configuration before they made it in the lab. I had it on my table, and when I found out that they were actually trying to well, that they had actually made it in the lab, synthesized it in the lab in 2007. On the 3rd, I submitted the work, which was later copyrighted that year. Here's some of the early work on the beginning of the universe. How the early universe would have begun with a large gravitational sphere. Actually, it's very small, the size of a Planck length. Mass of the entire universe starts to spin. The definitions have been updated since, but the idea is that the temperature increases, the pressure increases. Uh, Actually, the pressure becomes defined. Uh, I'm actually showing a change in volume first, and then the pressure. And this changed later on. I was able to show this mathematically how the theory has worked itself up since 2002. Most likely, the early universe Big Bang occurred according to the Fibonacci sequence, and it was relatively flat, showing that lambda would be equal to 1. I think this pretty well says everything that I want to say in this video. Look forward to my upcoming disclosure of the theory of everything. I'll do all of the 4 force problems with a single equation, and look for my book on the Amazon shelf. It's actually tucked away on the electronic shelf, so you'll have to there's print on demand. But it's gravitational unit theory, unified field theory, the theory of everything. Thank you for your time. My name's Todd Gooch.